Okay, hello everyone. Welcome. Good evening. Can you hear me? Okay, just we're waiting some time, then we'll start.
Afternoon, mister. Yes, we can hear you.
Okay, thank you. Okay, so we will start today's session. So hope all are you well. So basically today is our third day's online training program. So I hope you already get all of you previous recorded class, mainly recorded video class and also practice code. Okay. So after completing the 3 hours live training, then we talk about the problem solving class for the assignment or any other problem for the previous classes. Then we discuss about that. Okay. Okay, so let me share my screen. Okay, can you see my screen? Yeah.
Yes.
Okay, thank you. So let's go. Okay, so basically we discuss about that today's session, calculating any indices from satellite images and how we can easily filtering and displaying the signal to and monitor the different types of indices, suppose NDWI or NDVI, and how to extract the water body using a threshold technique, and how to calculate the different types of indices time series chart or export any shapefile from Google Earth Engine, how to add the legend and how to make the flood mapping, and also discuss about that annual and monthly time series chart for the different indices or different data set, how we can easily create for annual or monthly. So previous class I discussed about that how we can easily make the time series chart, mainly ready-made data set. Okay, so we are use the Modis LST and then we try to make the time series chart. But today we'll discuss about that also how we can easily make the monthly time series chart. Suppose I need the time series chart for each month from 2000 to 2020. So all of month I need this time series chart or annual time series chart, because different types of analysis we need the this temporal, suppose monthly or annual. So this type of temporal is very important for the different types of analysis. So that's the reason I also discuss about that how we can easily work with monthly and annual time series chart. You just apply the same process for any data set. I hope it will work, no problem. Okay, so let me open my code editor. So first of all, I discuss about that how we can easily filter our satellite images by seasonal. Okay, suppose different time we work with, suppose rainy season or summer season or any other specific season. So how I can filter my time series chart or time series image collection seasonal. Suppose I want to work with Sentinel-2 satellite imagery, but I need the satellite imagery for the two time period. Suppose two season, rainy season and or summer season. So how I can filter this type of seasonal image collection, we also discuss about that. And then how we can easily use this type of image, and further how we can easily extract the water body. And in the rainy season we find out the lot of water logging area, basically in the urban city. So this type of urban water logging area, how we can easily identify or detect, so we also discuss about that also. So let's go step by step I try to explain all of those, then you can easily get the more better idea. So first of all, seasonal, how we can easily filter the seasonal image collection. So first of all, we need to import our image collection. Okay, so previous class you already know about that, how we can easily import the image collection. Just click on the browse data catalog and then find out your image. So in this case I want to work with Sentinel-2. Just click on the Sentinel. So here we find out that Sentinel-2, all of Sentinel collection, Sentinel-1. Okay, so I want to work with suppose Sentinel-2 multispectral instrument. This data set I want to use. And here we find out that you can see the surface reflectance on top of atmosphere reflectance. So I want to use suppose surface reflectance. So this surface reflectance data set, if you check, we find out this type of scale. Okay, so basically this type of suppose reflectance value, suppose aerosol, blue, green, red, it mainly this data set mainly provide as a digital number. So this digital number we need to convert into reflectance value. Okay, so for converting we need to use this type of scale. Okay, so not only for that, you can also check suppose other data set, suppose Landsat, surface reflectance, we also find out this type of scale value or offset value. So this type of scale value or offset value we need to use to convert digital number into reflectance value for converting. Okay, otherwise it not show the proper reflectance value, or electromagnetic value is not showing properly. It show the digital number, very high value. So when you just multiply this type of scale value, then it just show the proper reflectance value or wavelength value we find out proper. Okay, so let's go, just simply import this image collection in our code editor. Just a paste. So now you can put any name as a variable. Okay, so before the variable name, we already know about that, always use the var keyword and put any name. We can put any name as a variable. In this case I put the name suppose image collection, or in this variable I simply put. So now this is my image collection. So this image collection I simply store it in this variable. Yes, any question please? Yeah,
Sir, I have a very small question.
please.
That is, sometimes we say for Landsat image it is 30-meter resolution, for Sentinel it is something else. What does this mean?
Okay, so basically it's called the resolution. Resolution basically it's different on the pixel size or grid. Suppose when you zoom a photo, suppose when any photo, it can be Landsat or any photo, when you zoom, more zoom, okay, then we find out the some square size sample or square grid we find out. So this type of square grid size is 30 meter for Landsat. This type of square grid size is the 30 meter, mainly pixel size. It's called the pixel size. So when pixel size is high, then we find out the resolution is low. Suppose I have a pixel size, suppose 1000 meter, 1000 meter. So my box or my grid is also big. Okay, so then we find out the resolution is very low. But when I have the pixel size is low, suppose I have a pixel size only for the 10 meter, so 10 meter, so then I find out the lot of small grid, we find out on my image. So then we find out the high resolution. Okay, suppose if the pixel size is high, then we find out the resolution is low. But when your pixel size is high, then we find out that resolution is low. Okay, basically if the pixel size is high, then we find out the resolution is low. Okay, so then this image is not good. If the pixel size is low, then we find out the resolution is high. So that's the reason we just use the different types of sensor. Suppose Landsat is one kind of sensor. So this Landsat pixel size is 30 meter. Okay, it means that this square, suppose this grid or this cell, it's the 30 into 30. Okay, square meter area, 30 into 30 square meter area. So this, it means that suppose 30 meter means that this cell size or this grid size 30 into 30 square meter. Okay, this square meter area, it means that. Okay, and when you work with suppose sentinel, we find out that it's a 10 meter pixel size. So this cell size 10 into 10, 10 multiply 10. Okay, so we find out that 100 meter square, 100 meter square. Okay, 100 meter square. Yeah, so now you can see we find out that it's a total 900 square meter for the Landsat, but sentinel is the 100 meter square. This cell size, okay, cell size basically cells is area. Okay, cell size basically 10, 30 meter, 10 meter, but this area when you compute just simply this. So we find out that it's a 100 meter square area and it's a 900 meter square area. So now when I work with, suppose I want to work with sentinel, so when you sentinel, we find out the lot of 100 meter pixel. Okay, suppose if I suppose this is my study area, suppose this is my study area, this is my study area, I simply draw. So this is my study area. So this study area, when I use sentinel, then we find out the 100 meter pixel size. So suppose it show the 100 meter pixel size. Okay, 100 meter pixel size, all of pixel, and how much pixel we can also compute this type of things also. So I'll also try to show you that how we can easily calculate the pixel number. Basically it's called the frequency. So pixel frequency we also compute after something, then you can get the more better idea. But now you can check, if I just use the sentinel, suppose this this study area, then it show me the all of pixel or grid, all of grid show the 100 meter square. So now it increase the cell number. So it help you to increase the cell size or number, we can say. Suppose cell size or cell number, it increase when I apply the 100 meter. But when I use the 900 meter square, so then cell size is not increase. Okay, so we find out the low cell size than sentinel because it's the 900 meter. So you can check, suppose this is the 900 meter, also this is the 900 meter, so it's easily fill up. Okay, just suppose few cell when I work with the Landsat, but when I put the sentinel, then it provide the more cell because it's the 100 meter square area. But when you work with the 900 meter, we find out the very few cell. Okay, not mass. Okay, less than sentinel we find out. So now what happened? So if this cell size is we find out the 100 meter square, then cell size is increased, then cell size is increased, but when I put the 900 meter, cell size is decreased, mainly low cell we find out, or decrease. I just try decrease. So now what happened? So it's a 100 meter, it's a 900 meter. So 100 meter, it's lot of cell. Okay, we find out the big cell number or cell size is increased when I use this study area. It means that it provides you the more information. So every cell or every grid give you the information, mainly pixel value. Suppose in this case I just use the 100 meter in this area, mainly 100 meter, mainly sentinel. So then it creates a lot of cell, and lot of cell give me the more information, and my image quality is also high. But when I work with Landsat, suppose for this area, so 900 meter square per cell size, then we find out the only few cell is cover my study area. Suppose cell size is very high, cell size is 900 meter. So then it not provide you the more better resolution, or it not provide you the good information. Okay, so this is the basic things about the cell size and how it will be work. I hope you can get the idea. Not only for that, we also use the different types of cell size. Suppose MODIS have the different types of cell size. MODIS, it can be, we can use 250 meter cell size, also use 500 meter cell size, also use 1000 meter cell size. So different cell size. So from this we can get the one idea. When you work with a small study area, suppose I have a only for very few small study area or very not very mass big study area, then we try to use the freely Sentinel-2 is more better. So for the small study area, when you analyze, you try to use the Sentinel. But when you work with big study area, You can also use the Lancet, no problem. But when you suppose for you have the only for the small study area, then you try to use the Sentinel. But Sentinel have the another limitation, because this Sentinel is available from 2015 or 17 something, 2015 to 17. It's available from 2015 or 17. But Lancet, it's available from your 1973 or 2, something like that. It's available. Okay, Moody's maximum it's available from 2000. Okay, so this is the way. Sometime we need the historical data analysis, suppose land use, land cover changes, or vegetation changes, or flood mapping, different types of work for the historical data analysis data. But for the present time on or near, use the Landsat or NDVI, so it also help you. Okay, as well as sometime we also use the different types of other data. Suppose we simply use the drone imagery. Okay, so it's also more high resolution. Okay, as well as we also use some commercial satellite imagery, suppose commercial, so it also more high resolution, suppose spot. Okay, spot 1, spot 2, spot 3, as well as we also use at the maxer. Okay, so it's the commercial, this type of satellite, or we can also use at the planet. So different types of commercial satellite imagery is also available. So we also use for the more small area. Okay, more small area when you try to work. Or also we also use the LiDAR data. Okay, this type of things. So this is the basic things about that for the pixel size and resolution. So if the pixel size is low, then we find out that it's a high resolution imagery. And if the pixel size is high, then we find out the low resolution satellite imagery. Yes, please, any question? Yeah, please.
Yes, thank you for that kind of explanation. And my question is about what is the interval in terms of all these platforms? Maybe I just want to maybe use the drone imagery and then later integrate the Landsat, the Sentinel, the Moody's. Is it possible? Like, how many days interval does this platforms provide the images?
Mainly you just merge Landsat, Sentinel, and Moody's. Yeah. Okay, I don't guess it.
Sorry?
Okay, I cannot understand your question.
Like, what is the interval at which you can get the images? Like,
oh, revisit day.
Sentinel.
Revisit. Yeah. Is it revisit day? Suppose revisit basically, suppose for the same place, when I get the image, it's called the revisit. Suppose for the Landsat, it's the 16 days. Okay, every new place we find out the imagery for the 16 days. Sentinel, it's the 4 to 5 days we find out. Okay, and Moody's it's available for the different times, suppose 8 days, or some data says 32 days. And this information you also find out in our data set. Suppose you can see it show the information 5 days. You can see the revisit interval, it's the 5 days. Okay, suppose revisit, suppose I am in Dhaka city, so I need the next image in the Dhaka city. For the after 5 days I find out this. Revisit every 5 days we find out the satellite imagery in the same place. For the Landsat we find out the 16 days. Okay, and Moody's have the different temporally find out. Okay,
is it possible to know, like, maybe I just want to compare between the drone imagery, like, and even with Sentinel, so that I can take the images at the same time, like for a small plot area?
yeah, it's also possible. Just simply merge. We can also merge, suppose Sentinel data and also drone imagery, then we'll also check it, no problem. It's also possible to it. Okay, it's also possible. Okay, so if you can get the idea about that, how we can easily work this type of resolution or cell size, okay, and how to correlate with the image quality or resolution. Okay, so this is the image collection I simply imported. So now this image collection need to filter. So where you need the image, and how you need the image, and when you need the image, just apply this 3 condition and filter. We already know about that, how we can filter this type of satellite image collection. So let's go. I will try to show you that. And I want to filter this image collection in the 2 season. Okay, this is my main goal. Suppose I want to filter this image collection in the rainy season and summer season in year of suppose 2024 or any specific year. Suppose just put here the filter.
Sorry, I can't see your screen.
Ah, just now it's okay.
Yes, it's okay.
All right. Okay, just put here suppose filter bounds. So filter bound basically where you need the emails. So further we already know about that. We can simply import our study area, any shape file or anything, simply put. Just pop from the asset tab, just import your shape file. So and work with suppose Dhaka city boundary. Just post, and I put the name suppose RY. So where you need the image, I need the image for RY. So just put here RY. Okay, so this is the where you need the image. Then I simply put here suppose when you need the image. When you need the image, so simply put here, or how you need the image. Anything you can put. Suppose filter date I put. Suppose I need the image in year of 2024 January to December 2024 December 31. And now how I need the image. Suppose I need the image, suppose filter date or filter metadata I can also use to filtering image properties. Okay, this is the one way. If you want, you can also use the another function. So if you check now, Google Earth Engine also deprecated some function. So for the future time, we will not use this type of function. You can say it's a red color. So it means that you can see it show the result, it's deprecated. So we are just use the new function, this type of use the filter with this type of things. Okay, so now we also use the new function because after future time this type of function is not work. So it also work, all there is no problem, but we try to use the new method or new function, it will be more better. So just put it the filter Earth Engine filter less than. Okay, then what less than what, just simply put the value. So now call the image properties. So image properties, just I call from here, this is the image properties. I use suppose cloud pixel percentage, and now put here and then put the value. Suppose I put the less than 1. Okay, so this is the filtering. We simply filter, and if you check how many images are available, just call the image collection and check and run the code. So now it display the result, how many images. We find out the 25 images, less than 1% cloud for my study area in Dhaka city. So now this 25 images further I try to filter for season. Suppose I need the image for the rainy season or dry season or summer season. Okay, simply filter this image collection. So another thing is very important, because this type of image I need to reproject the scale value. Reproject scale value means that convert digital number into reflectance value or wavelength value. Okay, it's very important for this type of, we can see it show the scale value. Okay, so this type of scale value I need to multiply all of images. Okay, all of images. So in this case 25 images I have. If I just simply use here the multiply, then it shows some problem. If you check the problem, suppose 0.0001. So suppose I need to multiply 25 images. So if I run the code, it show a problem. So this is the problem. It show the result image collection is not a function, or multiply is not a function. So now how I can use, how I can multiply. So in this case, I create a function. We already know about the function concept. Okay, it's very important because a lot of time we are use it for the different purpose. So I have a function. So I create a function. This function help me to multiply all of images individually 0.001. So how I can create a function? So let's go try to create a function. So for that, just take a variable. Suppose I put the variable name is rescale. Rescale, basically we simply multiply all of those, so we create a function. So put the function keyword, then I just take the only one element img and then put the curly bracket. Now I put my argument, what I need. So I want to need this element return. Okay, just a minute. Okay, it just stop the sharing. Why? I think some networking issue, that's why it just, yeah, so now it's okay. Okay, so what I return from here, so I want to return, what's the problem? Okay, okay, so I want to return this image or this element multiply with 0.0001. So this is a scale value, so simply multiply 0.001, and it's just cover only for the one element, but I need to cover all of element which is available between this time period 2024 1st January from December 31. So just apply the copy properties. So just use here the copy properties. Okay, copy properties of this element and apply system time start to system time end. So this is the function. So now this function need to connect. So we can connect this type of function two way. First way, if you want, you can simply copy the variable name. Just copy this variable name, because this variable is stored total 25 images. Okay, just copy and then paste here and connecting map function. Okay, for this connecting this function and close the bracket. So this is the one way to connect the function. Another way is that, so I just create this function in the same variable, not take the other variable, just I use the same variable. Suppose I put the variable name is image collection, this variable, I just use the same variable and create the function. So let's go, just simply paste here this function which I created, just paste it. So this is my function. Okay, this is my function. So now I want to connect with my collection, just use here the dot map function and connecting. So now we are just use the same variable and also same variable for the function. Okay, so you can see this is my function which I created. Okay, basically we simply multiply, and this is my collection, so simply connecting using the map function. So this is the another way. Any way you can follow, no problem. Suppose just use only for the one variable, and under this variable we simply create a function. This function simply connect with our collection, okay, using the map function. So now what happened? So now all of images in my collection, I have total 25 images, is multiply 0.001. Okay, so if I run the code, you can see now it shows the total 25 images. So now this process is also done. Okay, mainly convert digital number into reflectance value. So now further I just simply make the seasonal filter. Suppose I need the image for dry season and summer season. Suppose I need the image. So now I have total 25 images. So this total 25 images I need to filter. So for that, just take a variable, suppose dry image, and I want to filter this 25 images for the dry and summer. So just call the image collection, because it is stored all of images. Just copy and paste here, and I want to filter. Just put here the filter, and how I can filter? I want to filter using the calendar range. Suppose for the dry season have a calendar range. Mainly suppose dry season, it will be start from suppose January to June, or any specific season. So for that, apply earth engine dot filter dot calendar range. So it's one kind of function. It's called the earth engine filter dot calendar range. So basically this function help you to filtering data season wise or calendar wise. Oh, sorry, it's a lowercase. Yeah. So calendar range. Okay. So now put the calendar range. Suppose first start range, then in range, and then unit. Suppose start, it will be start from the January up to suppose June. Okay, I put the month number January to June and put the unit basically month, so put here that month. So now what happened? So now this variable is stored only for those images which images are available between this season in this month in 2024. Not only for that, suppose you take the more year. Suppose you want to identify from 2000 to 2024 only for summer season you want to analyze, so then simply change the time period. Suppose 2000 to 2024, but I need only for the specific season, suppose summer season, so then apply the same process. Okay, then what happened? So now then from this time period 2000 to 2024, it just take only for those images which images are available between this range, between this season. Okay, all of year it take this. So in this case I just show the 1 year. So suppose I just work only for the 2024 two season. But when you work with so different purpose, where you use this type of things for the multiple year or big time series data analysis, only for the summer, only for the rainy season. Okay, so the different way we are just use this type of things, then just apply the same process. Suppose I take the total 20 years data, but I need only for the summer season, so then apply this type of technique. Suppose I have total 30 years data and I want to work only for the rainy season, just apply the same procedure. Okay, so now it just apply the calendar range. I just put the month. So now let's check how many images we find out for that. Just print and call the dry image and use here the size function. So now it's show you the result. How many images are available? We find out. We find out the 15 images between this time. Okay, between this January to June, we find out this type of month. So this is the first season I simply filtered in year of 2024, and then I need suppose another season, suppose rainy season or wet season. For the wet season, same procedure, just take a variable. I put the variable name, suppose wet image, and this wet image I want to filter from my collection. I already have a collection 2025 image collection, just paste here. And now I want to filter, so same function, filter earth engine filter dot calendar range, and now put your range for the rainy season or wet season. Suppose I put the time, suppose July to October I put this time, or you can put any month, no problem. Suppose July to October I put, and unit is month. Okay, so now let's check how many images are available. We find out for that. So wet image, use here the size function to compute how many images. So now let's check how many images we find out. So you find out, if you check, there is no image. Okay, in the wet season, basically rainy season or wet season, we find out that lot of cloud on our settle on the sky. So that's the region less than 1% is very difficult to find out. So that's the reason need to just increase that cloud level. Okay, so when you face this type of problem, suppose it show the 0, basically we just need the image only for the rainy season, and rainy season or rainy month we don't find out any image less than 1% cloud cover. So now simply increase the time period, mainly increase the cloud level. So when you face this type of things, just simply increase the cloud level, or if you want you can also increasing the time range also. Okay, so when you face this type of null value or 0 value, there is no image, then simply increase the time range, or you can also increasing the cloud level. So let's go put at the cloud level, suppose 5%. Now let's check what happened. Okay, also there is no image. So now try to check, suppose 10%. Now we find out 2 images. We try to use the 2 images for the rainy season, no problem. And another thing is that when you increase the cloud level, some cloud is also add in your satellite imagery. So inshallah next class I discuss about that how we can easily filtering the cloud or haze and get the very neat and clean satellite imagery in the rainy season. okay, or any place where there are almost cloud formation. So this mainly river bank, okay, then we try to discuss about that. So now we find out the image in the dry season. Yes, please, any question? Yeah.
Is there any case whereby when you try to filter in terms of the cloud percentages, you won't get an image at all?
Okay, so basically it means that now there is no image. Suppose this 7 to 10, less than 1% image is not available, then we increase the value, cloud level value, otherwise it's not need. Okay, so if you increase suppose 100%, 100% means that you include all of images, you just include all of images. So then you can also remove the cloud remover function, then we find out the neat and clean satellite imagery. Okay, it's also no problem. Suppose 100.
Yeah, because
Yeah.
I'm just asking because I was trying something here. I increase the percentage up to 100, but I still got a 0.
Then try to increase the time range. Okay, there is a two way. Okay, suppose some place, if you don't check, if we find out the null value, first you try to check the cloud level. Suppose you put the 100%, even it show the 0 or null value, then increase the duration. Okay, time range, then I hope you can get the image, because some place we don't find out the image. Okay, then we just simply increase the duration and also increase the cloud level, then we find out the image, no problem. Yeah. Okay, so in this case we find out that less than 10% is available for my study area, so just I stay in here less than 10%. So we find out the 20 ms and also 2 ms, 20 ms for the dry and 2 ms only for the rainy season. So I want to use this 2 ms and make the image composite, or if you want you can also use here the single date image. So previous class I discussed about that how we can easily work with single date imagery. Sometime you need to also work with a single date imagery, so it's very easy. Suppose you just simply copy, I want to check all of information from my imagery. So if you check, just simply print, suppose print weight image. So now I have only for the 2 images for this collection. So now I find out all of image collection information, so every image, so you can see it's an image collection. So now from here we can easily work with single imagery. Suppose just click on here, then we can get feature. From the feature you can see we find out this type of imagery properties, also find out the bands. Okay, we find out all of bands in here for this image. Okay, and if you check, it show the this type of feature only for the feature first image, second image, but not showing the image id. But previous time we also discussed about the image id. So this image id is not showing in this case because I just simply multiply with their element, you can see with the element at the same collection. So that's the region it's not showing the id. Okay, but when you work with single date imagery, don't use this function. Okay, don't use this function. Just, okay, let me show you that what happened. I also check it. Suppose just I simply comment this line. Okay, it means that I am not use the function. Okay, just without function I simply filter dry and wet season. So now let's check what happened, it's showing the id or not. So if you check the 2 image feature first image, we find out the id. Suppose now I can use the id and work with that. Okay, so you can see this is the another image, so this is the second image, this is the id. So just simply copy and paste id and display your imagery. Okay, then suppose just copy this id and then you simply multiply, because it's a single image we can easily apply the multiply function, and then we reproject or convert digital number into reflectance value. Okay, so this is the way. Sometime when you work with the single date imagery, so not need to multiply all of images with their scale value. Okay, so in this case I am not working with single date imagery, so I am working the composite. So for that I simply multiply and convert all of those together. So just I use it. So when I use this function, you can see what. Yeah, please, any question?
Can I ask something?
Yeah, please.
Please tell me this again about the function you used for digitally scale converting, and give a short brief again.
Okay. Okay. So in this case, function basically help you to reuse your code. So in this case, I check in this collection, I have total suppose 42 images. Okay, 42 images I find out. So I need to multiply all of images. I need to multiply all of images with this variable. I need to multiply 0.001. This variable I need to multiply all of images. So if I without function, suppose you can see without function, when I use the multiply function, just use here the dot multiply. So it create a problem because multiply function, it's only work for the image data type. Okay, it's only work for the image data type, but this variable, it stored the image collection. Okay, so that's the reason multiply, it show the result. You can see multiply is not a function. Okay, image collection flavor and multiply is not a function. It means that this variable is the image collection, or it's a image collection, but I just put the multiply function. Multiply function is only work for single image, not collection. It's only work for the single image. So for the region, I simply create a function. So in this function, one by one image just come and multiply with this value. So for that, you can see what can I do? Just I create a function. Okay, I create a function keyword and put the element name. So this is my element. Okay, so this element I need to return multiply with this function, but it has only for the one element, but I have total 25 images. So all of element where I find out, so all of element I find out between this time period 2024 January to December. Okay, between this time period, all of element including. So for that, after multiply, I just copy these properties. Okay, after multiply, I just copy these properties and it's apply system time start, it's indicating this time, and system time end, it's indicating this time. So between this time, all of element I just multiply with this value, but it's a function. Okay, it's a single function and it's my collection. So basically single image, it's come from every single image. Suppose I have total 42 images, so it's come from this collection because all of images is stored in this variable. So for the region, I need to connect. So this function, I need to connect with this collection. So just use here the map function for connecting. So just I put the map function and just simply connecting this function which I created. So now from this collection, one by one image just come in my function and multiply. Okay, all of images. Okay, so I hope we can got the idea how it will work. Okay, thank you. Okay, so we find out this type of image collection. If you check, we find out the total 42 image collection, and in this case I am not using the single date imagery. So for the region, I just multiply, okay, all of images together. But when you work with a single date imagery, just simply skip this part, then take the image ID and then multiply, because image, suppose I have an image, single image. So single image, I can easily apply the multiply function. Easily I can easily apply 0.001 and multiply when I have a single image. But for the image collection is not possible, because multiply is only work for the collection. Okay, so when you use the collection, just apply the function and connecting with the image collection, then it will be work. Okay, so now you find out this type of dry image and wet image. Okay, I want to create the composite and display the dry season image and also wet season image in my map. So for that, we just apply the composite. So different type of composite, you already know about that. So take a variable. Suppose I put the variable name is image dry, and then I just call the dry season. I have total all of images, just simply call mainly 20 images. This 20 images I just create medium composite and clip with my shapefile, which is ROI. Okay, so now display the image, or just I create the another composite for rainy season or wet season. So just put here, suppose image wet, and call the wet image. Just call the wet image, and I want to display just map dot add layer. I want to layer for this image dry. Okay, so now run the code and also focus the given study area. So use add map dot center object is ROI, zoom level suppose 10, and run the code. So now we directly focus on your given study area, and we find out this type of satellite imagery, okay, without, it's a default color combination. So I want to add suppose band combination. Suppose I put here red, then green and blue, and I keep stressing, suppose keep the 98% and apply. So now we find out this type of composite. And this visualization I need to import in my code editor. So for importing, just click on the import. You can see a new line of code will be added in here, visualization parameter. Just copy and paste after the object. I put it say image try. Okay. So now same procedure apply for that wet season. Just map.add layer, and I have to add the layer for image wet. Okay, just run the code. So now it's added the another layer for wet imagery. So click on here again and then set the color band combination for wet image, suppose red, then green and blue. Stressing I keep 98%. Then apply and also import this visualization. So when I click on import, a new line of code added in my code editor. Just copy this variable and set after the object name. Okay, so this is my object. So after the object we always keep the visualization parameter, then put the layer name. I put the layer name, suppose image wet. So now run the code. So now it's added the two layer. So dry season image and wet season image, we find out. So you can see, find out this is the rainy season or wet season, and this image for the dry season. Okay, you find out this type of imagery. You can see in the wet season, they find out the some cloud. You can see also get this type of cloud. But when we apply the median is also help you to remove the cloud. Okay, median composite, it also help you to remove the cloud also. But we also find out this type of imagery. So now I want to use these two images, and further suppose I want to identify surface water. Suppose I want to identify surface water for dry season, and also identify suppose surface water in Dhaka in the rainy season. Then we find out that how much area we need to calculate. Suppose how much area we find out the water in only for the rainy season. Okay. So for this analysis, we need to extract the water body. Suppose this is my satellite image. So now from this satellite image, I just extract the water body condition or water body map I want to create. So for the water body map, or when you work with the water body, you are just use the different types of indices, water indices. If you simply search on the Google, suppose water index in remote sensing, we find out the lot of paper or lot of things we find out. Suppose let me show you the one. Suppose from this website, if you check, this is the different types of water indices and their application. You can check all of those from here. So you can see this is the one kind of water index, normalized difference water index, and this is the formula. Okay, and we are use the different purpose this formula. Also you can check this type of information later. I will send this type of things in the material section. Also you can see this is the WRI, water ratio index. So this is the another remote sensing water index. So, and this is the formula. So when you compute the formula, then we find out the water ratio index map. And also there are a lot of uses for the different purpose. And if you check the value, basically negative value indicating about the there is no water, and high positive value indicating about the high density of water we find out for this type of place. or maximum water we find out. Also you can see this is the another, it's called the MNDWI, modified normalized difference water index, and this is the formula about that. Okay, also you can see the NDWI formula. Okay, and range always we find out the -1 to +1. Okay, and water has value greater than 0. Okay, basically greater than 0, all of positive value indicating about the water pixel. Okay, so when we apply this formula, and when you take only for those pixel value greater than 0, it's indicating only for water body. Okay, so but we also compute this type of value also, because for the some region have some different value indicating about the water body for the remote sensing reflectance. Okay, so you can see different types of index for water body were also used. Not only for the, you will simply search on the Google, or different types of journal use the different types of index. So now how I can compute this type of index in Google Earth Engine and compute the different types of water index value, or create the different types of map. So for that, suppose I want to apply a formula for water index in my code and then check the result. So compute the indices. Suppose NDWI, I want to compute. So basically, if you check one formula is that green band minus near infrared band divided by green band plus near infrared band. So it's one kind of formula of NDWI, but not only for the NDWI, lot of formula is available. You can use any one for the different purpose. So you also try to read this website which I send you, then you can get the idea. Suppose some water index help you to identify for, suppose crop water stress index. Okay, water body, different types of things we use for the different types of water index formula. Suppose I want to use the formula, but same process when you compute. So this formula how I can compute in my image. Okay, so there is a lot of way to compute this type of formula. So one way is that we can simply apply a function. It's called the built-in function in Google Earth Engine server. We simply use the built-in function and compute this type of index. It's called the normalized difference function. If you simply search here, what is normalized difference function? Simply search here. Okay, so I will send you the link, you try later. Okay, so I will send you the link, then you try later. All of material you can easily access from the Google Classroom, no problem. Okay, I'll share all of you, no problem. So simply search here normalized. So you can see normalized difference function. If you check this function, normalized difference function, it's only work for the image data type. Okay, but sometime we need to apply this function on the image collection. Okay, so when you make the time series chart for the different types of index, then this type of function we need to apply on the image collection. Suppose I want to make the NDWI time series chart. So now this function I need to use and compute the NDWI from every images. Then this function I need to apply on the image collection data type. So for that, what can I use? I simply use the function concept. Function, basically I just reuse my code and compute all of images NDWI one by one, and then it's create the image collection of NDWI. Then we can easily make the time series chart of NDWI. So now normally it's work only, this function is only work for the image, but when you use the function, suppose when you use this type of function, then we can easily compute the NDWI or any normalized difference between any two band, and we can easily connect with the image collection. So I will show you that after some time, then get the more better idea. So now I want to use this formula. I want to multiply this formula using this function, and it's the image data type. So this function I can easily apply on my image. I already create the two images, dry season image and wet season image. And if you check what is the argument about that, this argument is the band names. Okay, and this it's compute normalized difference between two bands, only for two bands. Suppose all of equation, all of index or indices we have only two bands, then we can easily compute this function. Okay, then we can use this function and compute the indices. Suppose ndvi, ndwi, it's only have the two bands. Suppose in this case you can check green and near infrared only for the two band, green and near infrared only for the two bands. So I simply define the first band and second band name. Then this function automatically computed as first band minus second band divided by first band plus second band. Okay, it's automatically computed first band minus second band divided by first band plus second band. Okay, and compute this analysis. So now how I can do it? So very easy, just take a variable. Suppose I put the variable name is ndwi, suppose dry equal. So now call the dry season image. I already have, just copy it, store it the dry season image, and I apply normalize difference between two band, green band and near infrared band. So I define the band name. So green band, it's called the B3, and near infrared band for signal 2, it's called the B8. Okay, so if you check the band name from this information, you can see B3, it's a green band, name is the B3. And what is the near infrared band? Near infrared band is B8. Okay, so we have just used this band B3 and B8 and compute the ndwi. So now let's check the result. I need to display the map. So just map.add layer and call the ndwi dry and run the code. So now it's added the another layer of ndwi for dry season. So it create this type of gray color, grayscale color. If you want, you can also add the different types of color. Okay, so this, you can find out this type of map. If you want, you can simply click on here and add the color. Okay, different types of color. Suppose I just stressing and add the different types of color. Suppose I click on the plated. Suppose I put the here, there is no water, it shows a red color, so I put the red color. Then I put it, you can use the different types of color. Suppose I put it that yellow color. Then I put here suppose green color. Then I put here suppose blue color. So different types of color we can simply set. And now if I just apply, so then check what happened. This type of color is added in our map. So from this map we can easily get the idea, this type of blue color indicating about the water body, and others is the not water. So you find out this type of blue color is the water. So this is the water body map in dry season. So just import the color and copy this visualization and paste after the object name. I set the color visualization parameter and put the layer name. You can put any name. I put the name suppose ndwi dry. Okay, so now I apply the same procedure for rainy season. Just use the same line of code, just I copy and now compute ndwi for wet. Change the variable name, suppose wet, and call this image, just call the image wet. Okay, and paste here. So now it's compute the map ndwi in rainy season. Just check the result, and now ndwi wet, run the code. So now it's added the another layer of ndwi in rainy season. We find out. Let's check. Okay, suppose I want to add the same color. Okay, so suppose from this layer and this layer I use the same color, so then it will be more better. So just I click on here and you can see the pen sign. Just click on the pen sign and copy the color code. Okay, then open this layer, click on the setting button again and just paste here. Click on the plate it, and then click on the pen sign and paste all of color, and then okay. So now it show the all of color added, and then stressing 98% I keep and apply, and then import this visualization, then copy and paste after the object name, and I put it say NDWI. Wait, so now you find out the two map. It's added the two layer for different season of NDWI. We find out. Now you will check the map. So we find out the some place where there is no water in the dry season, but rainy season we find out the water. So if you check, we find out this type of result. So this is the dry season condition and this is the rainy season condition. Okay, so you can see this type of part. We find out that there is no water in the dry season, and if you check the rainy season you find out the water, this type of place. Okay, also suppose this type of place, we find out this type of blue color indicating about the water body. And it also more better, you can get the idea. Suppose just check the pixel value. So now just click on the inspector tab. Suppose I just click on this water body pixel. So now for this coordinate, what happened, we can also get the idea from this value. If you check the value, we find out the NAWA dry season, it show the negative pixel. Okay, so if the value less than 0 or negative pixel, it's indicating about that there is no water. Okay, and if the value is the positive or high positive, indicating about that water body. You can see we find out 0.6 in the wet season or rainy season. So rainy season we find out it's a water, but dry season there is no water. Okay, find out the negative pixel indicating about that there is no water body. But we find out the rainy season, we find out the water body for this type of place. Let's check others. Suppose just I click on here this type of pixel. So now for this coordinate, if you check what happened, so you can see the negative pixel indicating about that there is no water, in the dry season. Okay, but rainy season I find out the water body because it shows the positive value. So now how I can differentiate? Suppose I want to identify only for those places where I find out the water body in the rainy season. Okay, so how I can identify this type of place? So for that, we need to compute the value. It's called the frequency histogram. Suppose I just simply identify which pixel is the highest value for the rainy season and dry season. Okay, which number of pixel value for NDWI is highest in the rainy season and dry season. So from this highest value in the rainy season and dry season, from that we are just creating a equation, and just we are use this equation and then identify only for this place have water body in the rainy season, but there is no water body in the dry season. So let's go try to create. So first of all, we need to create the frequency histogram. Frequency histogram. So for that, take a variable, new variable. I say put the variable name is suppose chart, and apply the function UI dot chart dot image dot histogram. So this is the function. It's create the, for this image create a histogram, and I need to create it for, suppose for the dry season NAWI, and also it's in NAWI. Just paste here, and then put your study area. It's a ROI, and its scale value, suppose put the 10 meter. So basically, if you simply search this function on doc-step, then you can easily get the all of keyword and key value. In this case, I just put only for the value. If you want, you can also put the keyword and key value. No problem. Just use the dictionary, mainly curly bracket, and then put here the keyword and key value. So now I want to print. So just print the chart and run the code. So now let's check the console tab. We'll find out this type of frequency histogram and just open. So in this time we find out, if you check, it show the highest maximum number of frequency we find out, and this threshold value is the negative 0.8. okay, it is negative 0.8 because this place is not have mass water body. Okay, so that's why the total number of count we find out it's very high negative value. It means that from the chart we also get some observation for this study area. Suppose it means that for this place is not must have water body. Okay, because we find out that maximum number of maximum frequency number, we find out that negative pixel, negative 0.18. And if you check what is the highest, if you check what is the 0, 0 it will be start, this is the 0.023, this is 0. So now if you can also get the idea, you can see all of those value less than 0, basically this type of bar or this type of less than 0, all of value less than 0, we find out that there is no water. So from the 0 you can check the 0, so from less than all of 0 value. So from this chart we also get the idea for this place is not must have water body, because you can see maximum part we find out that there is no water, there is no water. Okay, and if you check like less than 0 and try to check in the right side, in the right side if you check very few number of pixel for water we find out. Okay, greater than 0, all of pixel greater than 0, it's indicating about that water body. So if you check from here in the right side, we find out that all of pixel who is greater than from 0, it's indicating the water body pixel. So you can see if you check it start from 0 or 0.08, or this is the middle value for the positive 0. So we start from here, so you can see 0.08. Suppose this is our start part, so 0.008, so this is the part. So if I apply suppose 0.008 greater than or greater than equal 0.008 in my NWI image, then I find out only for the water body. Okay, suppose greater than equal 0.008, if I just apply in my image in the dry season NDWI, then I capture only for the water body place. Okay, because it's the lowest value for my water, for my NWI in the dry season. Suppose I want to identify water body map, I just create from this histogram. So what can, which value I choose? I choose greater than equal 0.08 from the chart. You can see 0.08. So this is the 0. So from this 0, you just simply take the beside the 0, 0.008. So the greater than all of value from 0.008 indicating about the water body. So this type of pixel is water body. This type of pixel is water body greater than. So I want to display, suppose I want to display all of value greater than 0.008. So simply apply this condition greater than 0.008, then we can display only for this type of value. So let's check what happened if I just put only for greater than 0.008, then check what happened. Okay, 0.008. Okay, so let's, so just I want to apply this in my code and then check only for water body map. I put the suppose some note, then I can get the idea. It's a NDWI for dry, it's a dry. Okay, So I would identify suppose water body map in the dry season. So take a variable, suppose water map dry, and then call the NWI dry. And from the NWI dry, I just take only for this pixel, which is greater than or equal 0.008. So now it's indicating about that only for the water body map. So I have to display it, then check what happened. Just put here map dot add layer and call the water body map in dry season. Just copy and run the code. So now it's created another layer. So we find out, you can see this type of white color. This type of white color indicating about the water body. This type of white color, if you check, it's a water body map in rainy season, or sorry, dry season. So if you want, you can also add the other color to put more better map, suppose. Or if that there is the another way is that we can also create only for the water body map. Suppose if you check the two color, suppose black and white, I want to remove all of black pixel, just keep only for the water pixel which I get from this map. So for that we also use the another function, it called the self max function. Self max function, it just take only for those value, only for water, and automatically remove all of other pixel. Suppose in this case, if you check this map from this layer, we find out this type of water body white color, and this type of black color there is no water. So I don't need this type of black color, I need only for this type of white color. So just I apply the self max. Self max is one kind of technique to convert binary class to single class. So it's called the binary class. Binary class basically it show the water body and non-water body place. Suppose this type of white color, it's the water body, and black color it's indicating about the non-water body. So I want to identify only for the water body, So for that apply the self max function, self max. So self max function, just apply. So when I self max function, when I applied, it display only for single class, only for water body. So let's go. Just if I run the code, then check what happened without color. Just I apply the self max. Self max just show you the value only for the water body, and black color is been automatically removed from here. So we can understand about that. Let me put the satellite view. So we find out, you can see this type of only display the color, mainly white color. This type of place we find out the water body in dry season, this type of white color. It also more better, I try to apply suppose color. So single class, just apply the single color. I know display the single color, suppose blue, and I put the layer name suppose as a dry water, and run the code. So now let's check what happened. So this type of color show as a blue color, and it show the dry water. So you can see we find out this type of place, we find out the water in the dry season. So you can also export this type of map and also work with the ArcMap software to display this type of result. So I'll also show you that later, how we can work with the ArcMap. So this is the water body map in dry season. We find out this type of water body map. So now we apply the same process for the rainy season. Okay, for the rainy season. But for the rainy season, we are not know which value is, okay, this value we need to compute. So for that, just apply the histogram again. So just copy the same line of code and then call our image. So now call the image for image weight. Sorry, NWI weight, because I want to create the histogram for NDWI weight. Just copy and paste here. And I want to, okay, I put this, it's an NWI for, just I put the note, then I can easily get the chart, run the code. So now I display the result, another histogram for NWI wet season. So you can see, just open. So this is the histogram for NDWI in the rainy season or wet season. If you check the 0, so you can see, you find out that this is the value 0, and then almost we find out the 0.08 same value. Okay, but in this case we find out that this type of place have the lot of pixel. Okay, lot of frequency is also high for the water body. But if you check this chart, oh, just a minute. Okay, I hope you can see my chart. Yeah, so if you check, we find out that, so for this, let's find out the lowest value. We find out 0. Where is the 0? Yeah, this is the 0, and after that we find out the 0.8. Okay, 0.08. So this is the lowest value for this, and you can see we find out the lot of water pixel. Okay, it's a lot of water pixel. We find out that. So now from where you want to apply the water body, just apply the same. You can see if we find out the 0.08 for this, just apply the 0.08 and then check what happened. So let's go. Just copy the same line of code again and paste here. I put this variable name is NWI map in wet, and call the NWI wet, and I choose greater than equal 0.08 and self marks, and to display this map, just use the same line of code, copy the variable name and change it, and it displays suppose another color, suppose as a red color. Okay, red color indicating about that wet season water body, run the code. So now if you check, we find out this type of red color indicating about that wet season water body, and blue color is the rainy season water body. But if you check, the one problem is the overlay. Basically, suppose some place in the rainy season have water, and also dry season also have water. So how I can differentiate only for rainy season water? Suppose this type of place, if you check this type of place, there is no water body in the dry season. If you check this map, there is no water body, this type of place. But rainy season I find out the water body. But if you check this type of lake, okay, so if you check this lake, we find out it's a water body in the rainy season, also water body in the dry season. Okay, both of season we find out the water body. But I want to identify only for those places where have the water only for rainy season, not for dry season. Okay, so these things how I can identify. Okay, it's very important, because when you work with flood mapping, basically using the Sentinel-1 SAR data, we are just apply the same concept. Okay, suppose you can see we find out the permanent water body. Suppose this blue color is permanent water body, and suppose this type of red color is the flood water. So now how I can identify only for flood water? Okay, if you check this value, you can see this type of place, it's a lake. So for this lake, we find out the water body in the dry season or rainy season, we find out the water body. Okay, but some place there is no water in the dry season, but rainy season we find out the water body. So now how I can differentiate the water body in the dry season, water body in the rainy season, how I can differentiate only for this rainy season water? So for that, we simply apply a technique. So let me show you the technique, then you can get the idea. So from the chart, we already create the histogram. So from this histogram, okay, let me open the histogram. So this is the histogram, and this histogram for your wet season, okay, or rainy season. So you find out the highest value, okay, and lowest value. We already checked, lowest value is the same. So now we find out the highest value. If you check, this highest value is for the 0.7 or 0.7 or 0.8 or 0.7 we consider, okay, for this rainy season. Find out the highest pixel value of NDWI. Okay, highest pixel we simply find out. Suppose 0.75. Or if you check the another chart for the dry season, what is the highest value? If you check, highest value is for the dry season, if 0.2 or something, you can see 0.2, 0.2. Okay, 0.2 we consider 0.2. So 0.2, 0.2, this pixel 0.2 we consider in this case. Suppose 0.2 is the highest value of NDWI in dry season, okay, and rainy season 0.7. So now from this two chart, suppose from the rainy season and wet season chart, we can set a condition and get only for the rainy season water. Suppose 0.2, in this case we find out. So we simply set a equation, then you can get the idea. 0.2, take a variable. Suppose this condition is that rainy season water or wet water, this water we can set NDWI wet season greater than 0.2 and NDWI dry season less than 0.2. Okay, so which pixel maintain this condition? Suppose NDWI wet greater than 0.2 and NDWI dry season less than 0.2, so it's considered as a rainy season water. So let's go try to apply this condition and then check what happened, it differentiate or not. So take a variable. Suppose I put the variable name is, suppose, wet water, and now call the NDWI in the wet season. So NDWI wet. So NDWI wet, we put here greater than 0.2. NDWI wet season or NDWI wet greater than 0.2 and NDWI dry season less than 0.2. So which pixel maintain this condition, then we consider it as a water body. Okay, only for rainy water body. So let's go, we try to check it what happened. Just add the layer, suppose map.add layer and call the wet water, and I want to display only for the single class, not for the binary class. So for that, just apply the self marks, and I want to display the color. When I apply the self marks, always we put the single color. So put the color plated. So put the color. Suppose I put the yellow color. So yellow color place indicating only for the rainy season water. And this type of yellow color, this type of place, there is no water in dry season. Okay, so let's go. Let's check the result. What happened? So I put it's a wet water or waterlogging area. Just run the code. Or flood water area. So let's check what happened. So if you check, oh sorry, I put the suppose it's a rainy water, and it will be more better. So now if you check, we find out this type of place or this type of pixel, we find out the rainy season water. Okay, only for rain. And if you check, suppose this is the dry water, okay, this is the dry water, and if you check this type of blue color, okay, it's the dry water. And also check for wet water. So this is the wet season water, this is the wet water. And if you check the pixel, so let's check the pixel, what happened. Suppose I want to check this yellow color pixel, just click on the Inspector tab and click on the yellow color, this type of pixel. So now you find out that dry and wet pixel. If you check the NWI dry, we find out that negative 0.6, okay, in the dry season. And I consider, you can see, I consider the value less than 0.2. Okay, so my negative 0.6 is less than 0.2. Okay, and if you check the greater than 0.2, so now let's check the wet season value 0.7. So 0.7 is greater than 0.2. So all of pixel which maintain this equation or maintain this formula, we find out. Suppose let's check the another. Suppose just I click on here. So now let's check it, show the value NWI value dry season negative 0.6, which is less than from 0.2. Okay, and also find out that greater than 0.2 in the wet season, we find out the 0.4. Okay, so 0.4 is greater than 0.2. So all of condition is filled. If you check, suppose click on here. So from this condition, we find out that in the rainy season, we find out this type of place, we find out the water body. Okay, but this type of place, there is no water in the dry season. We don't find this type of place, there is no water. Okay, help of remote sensing index. So now let's check. Okay, so anyone any question, you can ask me about that, please. Yeah, please.
Yes, sir. I want to find out, is it possible to apply the same concept? Let's say like you want to find out the NDWI in the plans, maybe the images were captured using a drone image, a drone.
Which image?
Like I want to find out, maybe I want to characterize some maybe a certain plant we have got different assertions, and then see what is the variation in terms of the
Yes, it also
the
possible.
water
Yeah,
in the leaves.
yeah, it also possible. It also possible. Let's apply the same process. Okay, so identify, suppose for that before and after. Okay, so before and after, just find out the value. Okay, so in this case, suppose for the dry season, suppose it's my before, and rain season, suppose after. Okay, then we simply check the variation. Okay, so his value is the variation. In this case, we find out the 0.2, because if you check in the rainy season, we find out the highest value it displayed the 0.2. Okay, so consider the 0.2, we simply set this equation and then identify only for the rainy season water and differentiate between rainy season and wet season, rainy season and dry season. Yeah, it also possible. So a lot of things we can do using this concept, identify. Okay, it was possible, no problem.
Thank you.
Okay, so now we try to compute how much area we find out this type of yellow color pixel. Okay, we try to compute the area. So for that, just apply the same concept. Okay, so the flood mapping is also same. Just I will show you after some time how to work with the flood mapping. Okay. Okay, so for that we simply calculate the area first. Suppose I need to calculate the area, how much area in the yellow color pixel. So basically, when you compute the area, first of all, you need to apply a function. It's called image.pixel area. Okay, image.pixel area. And you can see this function we can only apply for image. So I have a image. Of wet water. So I can easily apply it using this function. And you can see it return the image. Okay, it not return a value. It just return a image in which the value of each pixel is the area of that pixel in a square meter. Okay, so it compute the pixel area of that pixel in a square meter. So each pixel, every pixel, suppose in this case I have a 500 pixel. So this 500 pixel area it's compute and it's return a image. So from this image further I need to compute the statistical value, how much area. So further we can get the idea. So when you compute any raster imagery, first of all we need to apply this function to generate an image, and in this image it's compute the value of each pixel is the area. Okay, and this pixel area it compute is square meter unit. Okay, it compute the square meter unit, and it not return the value, it's return the image. So from this image further I need to apply the statistical function and compute the statistical value. But before that I need to compute each pixel area from my image. So let's go try to compute using this function is pixel area, and it returned the image. So for that just copy ee.image collection, take a variable, suppose area image, you can put any variable name, and now put this, and I apply here add bands. So simply connect this image with area I want to compute. I want to compute this area, wet water area, just paste here. So now when I apply this function, what happened? From this image every pixel it's compute the area in square meter, but it returned this function return the image in stored in this variable. So I want to compute. Okay, so I need to compute the total pixel area, total area. So it compute the pixel area of each pixel, but I need the total pixel area statistical value. So for that we need to apply the another function. It's called the reduce region. Okay, so reduce region it also work with the image, and when I apply the this function it's create the image. Okay, already know about that. It's create the image, and this is the function reduce region function. Apply a reducer to all the pixel in a specific region, and this function give me the all the pixel area. Okay, so when I use the function, this function give me all of the pixel area from this image, mainly wet water image, basically this type of yellow color. And when I apply the reduce region function, it apply a reducer to all the pixel in a specific region, and we can use the different times for the different reducer. Suppose sometime we need to compute the total value, sometime we need to compute the average value, sometime we need to compute the standard deviation value. Okay, different types, but we are use the same function reduce region. Okay, reducer can be different, so I want to use it. Just copy this reducer function and paste here, then create a dictionary. Just I make a dictionary, start and int, or if you want you can also directly can put the value without keyword and key value. I put the keyword and key value. So take a variable, suppose area, and then call the area image. So this area image I just connect with this function. Okay, because it is this variable is stored all of the pixel area. Okay, in a square meter unit. So I want to compute using the reduce region function. So just I put the reducer. So I want to compute the total area. So put here ee.reducer dot sum. It compute the total area, all the pixel. Geometry, it's your shapefile variable name RY. Scale is the resolution of your pixel size, 10 meter for my case, and then others not need, just I remove. So now just remove all of this. So now if I just print the area and then check what happened, just print the area and run the code. So it show the result if you check as a dictionary, okay, reduce region. So you find out the two properties. If you check, this is the area you find out. Okay, but it show the result in a square kilometer unit. Okay, a square kilometer, sorry, a square meter unit. So I want to convert into a square kilometer or hectare unit. So how I can convert this unit? So there's a lot of way for conversion. So easiest way is that, so basically this function give you the result in a square meter, but I need the result in a square kilometer. So for the kilometer, so you can simply divide, mainly conversion, a square meter to a square kilometer, simply conversion. So put here dot divide 1 into 10 to the power 6, or 1 is 6, this value. So when I use this divide with this value, we can get the result in a square kilometer. So now run the code and check what happened. So now display the result, how much area in a square kilometer in dictionary. So now if you check, we find the 298.91 square kilometer area we find out in the rainy season water. And this is the map for that, this type of yellow color place. How much area we find out? 298.91 square kilometer area we find out the water body. Okay, so anytime when you compute the raster, or any, suppose you also try to compute how much wet water, how much dry water area, you try to compute, same process. So you also try, then face any problem, then I'll also guide you, no problem. Same way, just apply the same code, just simply modify. I hope it will work, no problem. Okay, so anyone in question, you can ask me please. Okay, I hope there is no question. You also try first. Further face any problem for your own study area, then I'll also guide you, no problem. Okay, and all of those we can easily export. So all of raster or TIFF image we can easily export as a GeoTIFF file format. So same process, we already know about that, export image to drive. So you just apply the export image to drive, and further simply export all of layer, because when you work with the research paper or presentation, we need to download this type of GeoTIFF file, and then we also work with ArcMap or QGIS software to produce our map for the research paper or presentation. Okay, okay, okay. So basically if I share the whole script, then font will be more small. Okay, so that's the reason I simply increase my font size. I screen, then there's the, it also reduce the screen size also. Okay, so I'll send you all of code, you also try, no problem. Okay, otherwise if I just simply decrease my screen level, you can see, so this font is more small. So I think it was better, I just simply increase, then you can get the more better visualization. Okay, so I'll send you all of code, you also try to practice, and further face any problem, then simply inform me, because we have the 1 hours for the problem solving class, no problem. Okay, okay, so now I talk about the same another concept for that, it's called the flood mapping. Okay, so how we can easily make the flood map using Google Earth Engine, same concept, but in this case we are use the Sentinel-1 satellite data. So I already prepared the code for my own study area, so I hope you can also get the idea how it will work. So this is the flood map, if you check. So basically this type of red color is indicating about the flood water, and this type of blue color, it's a permanent water. Okay, this type of blue color, it's a permanent water, we find out. And how I can create same procedure if you check. So first of all, we need the two images. Basically, before flood condition, before flood, we take a satellite 1 composite. Okay, if you check, there's satellite 1 composite. And we also take the after flood. After flood, we also take the satellite composite. This is the after flood. And this type of black color, it's indicating about that water body backscatter value. Okay, if you check what happened, this is the before. In the before, it not mass water body pixel. Basically, this type of place, black color indicating about the water body pixel. So, but we also face the another problem. Basically, desert area, we face some problem. Desert area, mainly sand. This type of sand, this backscatter value is almost similar with the water body pixel value. So then we also face some problem when you identify flood in the desert area. Normally, desert area there is no flood, but when anyone just apply this type of things on the desert area, then it also face some problem. Okay, so recently I also faced this type of problem for the desert area. So when you apply this code and show the result, the water backscatter value same pixel for the sand land, we find out this type of problem. But for this type of area, there is no problem, and mainly desert area is not having the flood. Okay, basically for the EMN, we also face this type of problem for identify flood area, because this type of sand land or desert area, it show as a your water pixel. Okay, but water pixel backscatter value, we find out this type of place, this type of black color drag pixel show the water pixel. So in this case, we take the two season image. Okay, suppose we take the first image for the before flood, and after flood we take the image. So this is the before flood, this is the after flood. So you can say after flood, it increase the backscatter value of water. We find out a lot of place is the water. Okay, so after that, this sentinel 1 image have some noisy pixel. Okay, or speckle filtering. So this type of filtering we need, and just simply filter basically all of remove all of noisy pixel and clean, neat and clean satellite sentinel 1. So just we simply apply this layer. So basically it just remove all of noisy pixel or speckle, simply filter from our satellite imagery before the flood and after the flood. So this is the after the flood. Okay, so if you check, this is the after, this is the before. So simply remove all of noisy pixel from here. And if you check the flood inundation, so this is the flood inundation. Basically this type of place, there is no water. We find out this type of place, there is no water before the flood. When after the flood, we find out this type of red color, we find out the water, mainly overflow of water. So we find out this type of place. So it's a flood. And this type of black color, it's a permanent water body. Suppose this place have the water before the flood and after the flood, both of time we find out the water. So we consider it's a permanent water. So we find out it's a permanent water as a blue color, this type of place. But this type of red color, we find out the water, and this type of place, there is no water in the before the flood. Before the flood, there is no water. So in this case, we are applying the Sentinel-1 SAR data. So basically, this is the image collection, Copernicus Sentinel-1 GRD. And Sentinel-1 is one of the best satellite for flood mapping because it uses the SAR technique. Okay, we can see through the cloud and work day or night, and perfect for detecting the water during the storm or flood. Okay, we can easily perfectly identify the water body. Okay, this is the satellite, and we use the SAR, basically synthetic aperture radar SAR, and SAR have the sensor type, basically SAR or C-band. It also available. We find out that this type of polarization, suppose vertical polarization, or vertical horizontal polarization, mainly VV and VS. If you check the VV and VS band, and resolution basically 10 meter for the ground range detected, or GRD. It's called the ground range detected. It's a 10 meter resolution we find out. And revisit basically 6 to 12 days. Okay, 6 to 12 days. This is the revisit interval, 6 to, depending on the location and orbit. Okay, so it's passing the different orbit, ascending or descending. So lot of information for the Sentinel-1 SAR data, and there are a lot of uses in the remote sensing in the different sector, this type of Sentinel-1 SAR data. Okay, and if you check this, the information you also get from here. It's available from 2014 to present time. We also get this type of data. So it provides the very near real time data, you can see, and it applicable for the, it capture the information day or night. Okay, and any weather condition, suppose very cloudy or very strong cyclone, there are a lot of uses to identify. I can use it. So this is Sentinel SAR data. So basically flood area, we find out this type of, if you check, so in this case I will show you the code, it will be more better. Where is the code? Yes, this one. Okay, so first of all, you can see I take this imagery. This is the Sentinel-1 GRD, Sentinel-1 SAR data. You simply take and then simply filter. So filtering, there are a lot of process for instrument mode or orbiting pass, okay, or transmitter receiver polarization. So in this case, we are using the VS, okay, but recently we also find out the some information. VS is not more better for tracking the water. Okay, so we for VS basically vertical and horizontal, but VV is more better to extract the water body. So when you work with your real project, you try to apply the VV band. Okay, but in this time it's my previous work, so here I apply the VS, but now VV. So a lot of scientific, if you check, so they are used at the VV. Okay, so VV band they are used and then create this type of work. Okay, so but it's my previous, simply change the VV, then it will not work, easily work, no problem. And we take the IW. So what is the IW? Because we are using here the different types of instrument mode. If you check the information, what is the instrument mode? Click on the image properties. So basically in instrument we find out that IW, interferometric. So interferometric with SOT is the best. Okay, all time just use it, there is no problem. Okay, and orbiting pass, we take the ascending descending both of collection. Suppose orbiting pass, if you check the orbiting pass, where is it? Orbit pass. Okay, mainly direction of the orbit. Okay, ascending or descending. Okay, just okay, so we take the IW, instrument mode, and orbiting pass we take the both. Okay, all of image for the descending, all of image for the ascending pass of the satellite orbiting and descending. Okay, and now we take the collection, you can see. So this is my collection. So from this collection is simply filter before and after. So simply put the before flood. So basically this is the result for 2022. Okay, in the flood in Sylhet. So we just use it, this data. So this is the flood time. So we put it, this is the before flood and this is the after flood. Sometime we also face some problem. Suppose there is no image. So then simply adjust the range, okay, increasing the time period, then we can get the image. So basically revisit will be 8 to 10 days or 6 to 8 days, I think. Yeah, 6 to 8 days. So try to apply this friends, then you can get the imagery. So in this we take the before and after collection. Okay, and from where we set the VS, but now VV band is more work for extracting the water body pixel and create the composite using the mosaic and clip with our study area. Okay, and further we simply display this type of image. Okay, before and after flood we find out this type of image, basically these first two layer, before and after. So after creating the before and after, just need to filter. So this filtering process is very lengthy. So in this time I don't discuss about that. So just I use the same code, you can use it and then filter. So if you check, this is the SQL filtering function. So basically we are just applying this function. Okay, this is the function. We simply apply. So all of function, this is the function, you can see it's create a function. So function to convert from decimal number, it convert to dB. So this is the function for SQL filtering. So they are used at the 2 natural and 2 dB. Okay, these are the two function, 2 natural and 2 dB. And for the conversion process, they are mentioned in here. Also, you can check it from this link also. Okay, and you can simply check all of those. Okay? They are used the different types of function or kernel, different types of things that are used. So this is the function. All time use the same function to convert this type of thing. So this is the function. This function simply apply in your image. Okay, both of image basically after and before, and just connect the function variable name. So this function variable name simply connect with your image. So in this case we simply apply in here. If you check, okay, so we simply put the 2 dB, it's our function variable name, and 2 natural. Okay, so apply the before image and also after image. Okay, just use the same all time, no problem. And further simply display the image. You can see the before filtered and after filtered. So you find out this 2 layer, another 2 layer. If you check, it is the before filtered and after filtered. After that, simply apply the histogram technique. Okay, histogram technique, identify the lowest value. Okay, for the before flood, same like as for rainy or dry season. Suppose dry season water body, we identify the highest pixel of NDWI. So in this case, we find out the minus 20. So we just use the before filtered greater than minus 20 and after filtered less than minus 20 and apply the self marks. So same concept, we just make the single layer and identify for the flood marks water. If you check, this is the flood annotation, you find out. Okay, so this value is very important, because sometimes if you don't find this better value, then it also mixing with the phenomenon water and flood water. So simply create the histogram, okay, for your own study area and identify. Okay, and watermarks basically apply the less than, okay, before filtered less than minus 20 and after filtered less than minus 20 and self marks. Then we find out that water body. Okay, so same concept you also try. So this is the one process, just use only for the before and after filtered and make the identify for the flood water and permanent water. And further just apply the calculate the total district area or calculate the flood area. Okay, same process. Okay, this is the hectare unit we compute. Okay, if you check, okay, so same process, simply apply e.image.pixel area, and you can see at the same time it apply the reduced region function. But in this code where I compute the rainy season water, we just use the separate code. You can also apply this any method, you just put this method also, no problem. Okay, just first of all just apply this e.image.pixel area and then simply call this layer name. Basically it is stored wet water layer, I simply call, and then further apply the reduced region function. But in this code they are used the same time, suppose e.pixel area and also reduced region. Okay, so at the same time use, not take the different variable. Okay, same process, both of processing also apply, no problem. And you can see for converting there use this get sum, and you can also just multiply or this value, then it's okay, no problem. Okay, any question please? And further add the legend. So I also discuss about the next of the how we can add the legend, or you can also modify the same code, add the legend. Suppose I'll show you that how we can easily modify the code. So this is the legend. You can see first of legend position, it will start from here. So bottom right, so I just it show the bottom right. Suppose I need the result bottom left, so simply put here the bottom left. So now you find out the legend in the bottom left. And then you can check the this is it show the legend title. So you can put any title in here or change the title. In my title just only have the 2 color and 2 name. So if you check red and blue, so simply you can also have the another legend. Suppose I have the another legend, suppose I put the another color, suppose I put the color name is green. Okay, suppose first list flood annotation show the red color, water body show the blue color, suppose green color it show the another suppose anyone, suppose I put here non-flood area. I just randomly put here non-flood area or non-flood. So now in my legend I add the 3 different item. Okay, and if you check here it show the 2, so just put here the 3 and run the code. So now I hope it also added as a green color. You can see the non-flood. So this is the way any legend we can easily add. Okay, we can easily add using the same process. So first of all, you simply define the color name. Okay, all of color name. Suppose I create a land use land cover map, and here different color identify different types of level or different type class. So simply I put the color. Suppose red color indicating about the urban body or urban area, blue color suppose water body, green suppose another. So simply write the name, and now count how much. So 1 2 3. So just put here the 3 and run the code. It will be added all of color and also added the name. Okay, so just simply modify in this code in here, and you can also modify in the title. So simply put the title. Suppose I put the title is suppose LULC or anything you can put. Run the code. So now it also added in the LULC on the title. Just simply modify. And other suppose bottom left, bottom right position, you can also change in here, and also change the title, and also change the color, and also name of your legend item. Okay, just put the serially put the color and serially put the legend item, and now then count how much item. 3 item. So put here the 3, and other keep the same, not need to change. Okay, anyone in question, you can ask me please. Okay, I hope you also try first for your own study area. Okay, I also give some assignment regarding this type of topic. Then I hope it will be more practice for you. Yeah. So now we talk about that how we can easily compute any index in remote sensing. Okay, so we already use one technique. It's called the normalized difference function. Okay, we are just use the normalized difference function and compute only for the 2 bands. But in the remote sensing, where you here the different types of index, we is indicating different types of bands, more than 2 bands. Okay, so how I can compute? So I will show you this process. Then you can easily get the idea how it will work. Suppose I just import a satellite image from Landsat. Suppose Landsat 9. Proper atmosphere I choose. So this image I am to work. Just copy this snippet ID. And paste here. Then simply filter. Suppose take a variable image. Okay. So in this case, you can also import your shape file, or if you want, you can also draw your study area using the rectangle or polygon, or you can also take the point. Suppose I need this data for this area. Okay. So I put the point and I put suppose POI. So I need this image for my POI. So put here the filter bounds with POI, and then put here filter date. Suppose year of 2024 1st January from 2024 December 31. Okay, and now suppose I want to use the another way for filtering. We already know about that filter metadata. So this filter metadata, this function mainly filtering a specific range. Suppose less than 1% or less than 2%, 5%, like that. A specific range, it's filtering. If you want, you can also put here another function. It's called the which function? Short function. Short. Yeah. So sorting your data based on image properties. So this is another way for filtering the image collection. It's very effective. Suppose when you work with, you want to identify lowest cloud cover image for your study area. Okay, lowest cloud cover image you want to identify, then you just apply the sort function. Okay, then it provide you the lowest cloud cover image and this single image. Suppose between this time period for this study area, I need a image, single image, and this image will be lowest cloud cover image I want to identify. So I don't know which date or which image is lowest cloud cover image for my study area. I don't know. So for that we simply sorting based on image property. This image property is called the cloud cover. Okay, and put here the first function. So when I put the first function, and if you check, just print this image, it just return a single image, but we face a problem. What the problem? Oh, sorry. So we are not use the filter metadata, only use the sort function instead of filter metadata. Run the code. So you can see it show the one image only for the image. If you check the image acquisition time, all of information from the properties, if you check, this is the 0.07. So for this place, lowest cloud cover image is 0.07, and this is the acquisition about this time 2024-05-08. So this is the one kind of process when, yeah, please. Yeah, any question, please?
Why did it reject the filter metadata?
So we use another way for filtering image properties. So filter metadata, it's work only for the specific range. Suppose I need all of image less than 1% cloud cover or 2% cloud cover. But in this case, my target is between this time period, I want to identify a image, and this image will be lowest cloud cover image between this time period. So for this place or for this study area, I find out this time I find out the lowest cloud cover image. Okay, so this is another filtering for image properties using the sort. You can also use the filter metadata. It just help you to filtering a specific range, less than 1% all of image, less than 2% all of image, but I need the single image, and this image will be lowest cloud cover image between this time. Okay, then just apply the sort function, sorting. Okay, did you get the idea how it will work? So what the difference between the filter metadata and sort function? Yeah, so filter metadata is only work.
So you can do sort dot last, that means the highest cloud cover.
Yes, I think last function is not available, so let me check what happened for the last. Okay, last function, let's check what happened. So last is not the function for that. So basically this is the process we identify for lowest cloud cover image. Okay, so was first image indicating about the lowest cloud cover image, and if you just put here, suppose I put here the true, then let's check what happened. Okay, let me just put here the false. Yeah, so now we find out the last cloud cover image. This is the highest cloud cover, 96.08. so for this place, highest cloud cover image is 96.08, and acquisition time, this is the acquisition time. So when I use this image, okay, when I use the image, then I find out the highest cloud cover. Okay, this is the highest cloud cover, 96.08% for my place. So this is another way. Suppose I want to identify for my place which is the lowest cloud cover and which is the highest cloud cover. Just apply the false function. So when you apply the false function, then we find out the highest cloud cover image. And if I just simply ignore the false function, it shows the lowest cloud cover image.
So
okay. Yeah, please.
For filter metadata, it gives you the leverage to choose the percentage.
Yes.
But this one seems restrictive.
Yes.
So if in case you wanted like 10%,
yes,
or 20% cloud cover, how do you go about with this one of sort?
So it's not possible for the sorting. Okay, then we need to apply the filler metadata. Suppose I need the less than 10%, then I put the filler metadata function and take the cloud cover less than 10%. Suppose if I just put here the cloud cover, suppose less than 10. So then what happened? All of less than 10% image is stored in my collection. Okay, suppose if you check the result, suppose just I simply comment this line. So now it stored all of less than 10% image for my study area. Less than 10%, if I know the 6 image. Okay, this 6 image is the less than 10% cloud cover. So this filler metadata, it's work for the specific range. But when you just need the single date image, suppose highest or lowest cloud cover, then apply the sort function. I want to sorting means listing. I just make the list, and from the list I want to identify highest and lowest cloud cover. So when I put the false function, it display the highest cloud cover image for my study area. For my study area, we find out the highest cloud cover image. And when I put the true or without false, it shows the lowest cloud cover image. Okay, just single image. Okay, so I hope you can get the idea. So when you need the range 10%, 5%, 20%, then we can just apply the filter metadata. But when you need the single image, highest and lowest cloud cover, then put the sort function. Okay, and we find out that this is the lowest cloud cover image for this image, and this is the acquisition time. And if you simply click and drag it another place, so now for this place I need to check what happened for the lowest cloud cover image between the year. So for this year we find out this time 0.02% cloud cover this time. So this image is the lowest cloud cover image for my study area. Or you can also import your shape file, anything, simply import your shape file, or also import your study area, or draw the rectangle, anything. Okay, so I hope you can get the idea for the sort and filter metadata. Yeah, any question, anyone? You can ask me, please. Any question?
No, it's good.
Okay.
I was just making a suggestion. Since we've done the previous example with Lancet, can we do with Sentinel too? This one.
Same
Just to understand dynamics.
any image collection, apply the same all of filtering process, no problem. Okay, for the Landsat, Sentinel, okay, apply the same process, no problem. Suppose this technique you can also apply for Sentinel, no problem. Okay. Okay, I hope you can get the idea how to work this. I want to display the image, so just apply map dot add layer and call the image and run the code. So now this image style is loaded in my map. Okay, we can find out this type of image. Okay, so in this case you can see we find out this type of image. You can also use the point, line, polygon, or border, same process. Okay, so in this case I just take the point and display the image. So I'm going to add the visualization, same process. Suppose red, green, and blue. Stressing 98% I keep, and then apply. So these are satellite imagery. Okay, so now I can use the imagery and make the different types of remote sensing analysis. So basically we try to discuss about the how we can easily compute any index or any indices. Suppose I just use the image and compute the different types of index, then you can get the more better idea how it will work. So first step or first method we already know, it's called the normalized difference. Suppose I want to compute NDVI. NDVI is the normalized difference vegetation index. Near infrared minus red divided by near infrared plus red. So this is the band, near infrared minus red divided by near infrared plus red. So I can easily apply this formula using normalized difference because it's just only two bands, near infrared band and red band. So let's go try to apply. So take a variable, suppose NDVI, call the image, apply the function normalized difference between two band. Near infrared band name is B5 and red band is the before. So now it compute NDVI. So now run the code, call the NDVI and run the code. So now we find out the NDVI map for our study area. It show the gray color. I want to add the color, then it will be look more perfect. So now add the color. And you can check the result. It show the ND. Okay, so when I add any layer, it show as a band. Suppose NDVI is a band, but this band show as a ND. So you can also rename it. Suppose I want to change the band name. So for that, just use here the dot rename function, dot rename, and I put the name, suppose NDVI and run the code. So now this band name, it shows as the NDVI. Click on here, and if you check, so you can see it show the NDVI. Okay, because I rename it, and without renaming, it show the ND default name. Okay, so now we try to add the color. So first of all, stress in 98%. Suppose for the NDVI, I want to display as a blue color for water body. Then I want to use this type of color. Then vegetation display this type of color or this type of color, and apply. You can also add the more color, no problem. So now we find out, I also import this color and copy. So now we easily find out that water body show as a blue color and vegetation show as a green color. This type of things we find out. So this I put the layer name. Okay. So we can easily compute the NDVI and we can easily identify for vegetation. Okay, you can see this is the NDVI map. And if you check the value, suppose just click on the Explore tab and click on this, and now we find out the water body NDVI show as a negative pixel, negative value. Okay, so negative value indicating about that water body. And if you check this type of place, we find out the 0.8 because it's a cropland. And NDVI is very helpful for crop phenology. Okay, we can easily identify start of season, peak of season, end of season. So I have the another online training program only for agriculture precision. So then we talk about only for the agriculture related idea, how we can easily work with agriculture precision. So there's a lot of uses for NDVI, not only for the vegetation. In the vegetation, we are used at the different way. Suppose crop phenology, okay, or crop growth tracking is also helpful using the NDVI. Okay, or crop health is also indicating about the NDVI. So now you can easily find out this type of NDVI map. Okay, so we find out they can see this type of value. Okay, we find out that good vegetation, this type of place, it shows the high NDVI value indicating about the good vegetation, 0.7 high, no problem. So now you also try. So I will give the assignment or homework, you also try. So from that you try to identify, you just distinguish or separate. Suppose only for you try to identify only for the cropland. Suppose you can see this type of place have the cropland. So you also try to identify cropland and make the cropland map. Okay, just make the cropland map, help of NDVI. Okay, so these are homework or assignment you try. So you try to identify only for the cropland. So other trees or others not need, just identify only for the cropland. I think this process is also mixing with the other vegetation, but maximum cropland we can easily identify. You try. Okay, so this is the first step to identify calculating the indices. Second step we can, it's called the prerequisite. Yes, please. Yes, please. Any question?
Yes. Is it possible to compute maybe like the GNDVI, because what we understand is that the NDVI it usually saturates under high vegetation.
Okay, NDVI basically, if you simply search, let me show you the theoretical part. NDVI range. So simply search. So we can find out this type of USGS or NASA website, then we can get the more better idea how it will be worked. So you can see NDVI, the foundation of the remote sensing phenology. And if you check the NDVI, this is the NDVI theoretical part, you can see. So how reflectance value, so basically you can see strongly absorb the wavelength. Okay, you can see certain pigments in the plant leaves strongly absorb the wavelength of the visible red light. Okay, so you can see this type and this type of formula have a background or theoretical part, why NDVI is equal to near infrared minus red divided by near infrared plus red. So for that, if you check, suppose near infrared band is mainly reflected, more reflected for the vegetation. If you check the band pixel value from your image, let me show you the one example, then you get the idea. What is the code? So if you check the result, QA pixel. Suppose I want to choose dot select. I just choose only for the select. Suppose near infrared band and red band. Red band before. So now run the code. And if you check, suppose I just click on the vegetation. So you can see, find out that 0.3. Okay, so near infrared band is more reflected by near infrared by vegetation or dense vegetation. Okay, and red band is absorbed. Okay, you can see low value 0.05 for the vegetation. So that's the region we can easily identify. If you check, also compare the result for the visualize. Suppose just I show you that if I just display only for the near infrared band from the one band, if I just display it, it's tracing of 98%. Suppose high pixel value indicating about the dense vegetation. If you check, now we find out this type of result. So this type of white color indicating about the high reflectance value of near infrared, this type of red color. So it means that this type of place we find out the good vegetation. Okay, because good vegetation always reflect the high wavelength of near infrared bands, this range. Okay, so that's why you find out this type of place is the high NDVI, this type of place. And if you check the red band is the opposite. Okay, it's the low value we find out. If you check this type of place, you can see this type of place, it display only for near infrared band. And you can see this type of place have the good vegetation or good cropland, we find out it's a very high reflectance of near infrared. Just click on here, you can check the value. We found the 0.7. Okay, 0.7. And if you check, suppose this type of value 0.05. Okay, so this is the theoretical part, lot of background about this type of technique. So I think you also simply search on the Google, then you can get the more better idea how it will work, why NDVI formula is this type of value or this type of equation. Okay, then you can get the more better idea. Okay, and also read some theoretical part, you can get the more better idea. Suppose for the water NDWI, you are use this formula NDWI, it's suppose green minus near infrared divided by green plus near infrared, because green band is more reflect by water, so that's why you just apply the green. Okay, so this type of things is also behind on this type of equation. And if you want, you can also create new indices. Okay, suppose you just create any new indices, then you can also try to make a paper and also publish your new indices, because this type of indices is provide some scientists. Okay, because they are identify this type of reflectance is high, this type of absorption is high. Okay, then they make this type of equation. So it also possible for in the future, if you want, you can also make the more analysis, and you basically we are use the indices identify a specific feature from the surface. Okay, suppose NDVI, it's help you to identify for vegetation. NDWI help you to identify water body. Not only for that, we also use at the NDBI, it's help you to identify build up area. Okay, we need, as well as also use here normalized difference, normalized difference, barren land. Okay, it's also possible barren land, it's called the barren land index. We also use here ND or SAVI, it also help you to vegetation. Okay, soil adjusted vegetation index. So lot of index, and all of index have a specific theory or equation, it's provided by different types of scientists. So now we are using this type of things and also do different types of work for the remote sensing. Okay, so you also try, and further face any problem, then I also guide you, no problem. Okay, okay, I hope you can get the idea. Okay, so now for the second, we just apply the Drake equation. So let's go, just take a variable, suppose NDVI, and call, suppose I just call the band. Okay, suppose the equation, suppose put here the near infrared, subtract, suppose rate dot divided by near infrared plus rate. So you can see near infrared minus rate divided by near infrared plus rate. So this is the another way. In this time, we need to define what is near infrared and what is the rate. If I run the code, it show a problem. So you can see near infrared is not defined. So we need to define what is the near and what is the rate, we need to define. So for that, just take a variable. Suppose I put the variable name is the near and call the image. So basically this variable is stored at the image. If you check, this variable is stored at the image. So just I call and compute the NDVI.